Today, we will see in detail about the first phase of the compiler known as lexical analysis. This is the first phase of the compiler. You call it lexical analysis. It is even called scanning. It is even called scanning. As the name denotes, you scan or you look. This is what actually happens in this phase. You look each character or number in this particular phase. It is done by the lexical analyzer. The lexical analyzer, it is also known by the word scan. So now this is what we will be looking into today. The first thing what we will be seeing is what is the role of a lexical analyzer or the scanner. Okay, now look into the diagram below. You will be having a source program. The first phase, you call it lexical analysis or the scanning. It is done by the lexical analyzer. You do some things, you get a particular output which goes into the next phase of the compiler. So this is actually your phase number 1. This is your phase number 1 of the compiler. Now let's see what happens in this particular stage. Now here what happens is, imagine you do have something like this, radius equal to 3 or 32. Imagine you have a code like this in your program. Let it be any programming language. Imagine it to be C or CPP or Java or Basic or Fortran. Be it any language, you will have somewhere a code like this. What this particular scanner or the lexical analyzer does is, it reads each input character by character and group it into something called lexemes. Okay, now what is a lexeme? We will just see now. Now, it will group them into lexemes and produce the output as a set of tokens. Now, before we talk about that, let's see what do you mean by 3 things: tokens, patterns, and lexemes. We will see that with the help of an example. Okay, now look here. You will have something called, we'll go for the same example, radius equal to 32. I will be telling, this is something called a variable, or in terms of compiler, I call it by a name called identifier. Okay, so this is an identifier. This, I say it is an operator. It is an assignment operator, and this I can say it is a number. It is a number or a constant or whatever. So this particular statement, it has 3 things. It has an identifier, it has an operator, and it even has a number. Now let's come back. What do you mean by a token and a lexeme? Now, radius is a lexeme. Radius is a lexeme which follows a particular token pattern, which means you will start with an alphabet. Okay, when you think about an identifier or a variable, it will start with an alphabet. Okay, the first one will be an alphabet. The remaining can be anything else. Okay, you can have numbers, you can even have alphabets and all, because you can very much have a variable like R123. That is possible. You can even have a variable like R-123. All that is possible. Okay, so I can say that for a token called ID, which in my programming language, I call it by a pet name called variable. It is actually a letter followed by letters and digits, or depending upon my programming language, It can even be special characters and so on. So this is what you mean by a token. Token is the generalized name. Okay. And lexeme is, your variable names. For example, radius can also be a lexeme. You think about a number. When you think about a token like number, it will follow a particular pattern. It should start with a sign. This is optional. Yeah, you can start with the sign. It should start with the number. It can follow with a decimal point. You can have numbers again following that. You can even have exponents, and then you can again follow it by numbers and all that. So numbers, they follow a particular pattern like this. And an example, you call it to be a lexeme. When you again think about comparison operators, they can only be any of these. They can either be this, less than, greater than, less than or equal to, greater than or equal to, etc. And this is a sample. If you think about assignment operators, yeah, you only have one assignment operator, and that is this. The example is only a single assignment operator. So that is what you mean by a token and a lexeme. Now let's come back. We are coming back to role of a lexical analyzer. Now, the first thing the lexical analyzer does is, it does something into grouping of lexemes. Now look here. You start reading from the left. Okay, and you will first encounter something called R. And after R, you do have an A. According to the programming language, you should, after R, you should have actually an equal to sign if you're planning to assign. But you do not encounter an equal to sign. Instead, you are encountering another letter called A. You go on until you encounter all these. And after that, you will be encountering an equal to, which means all the things which you read till now, they are grouped together. You imagine it to be a variable. Okay, so that is what is meant by it is grouped into a lexeme and it is produced as a sequence of tokens. Now my compiler will understand this particular sequence called radius. It is a token of identifier or variable, and what your compiler does is this word radius, it is considered to be a variable. Equal to, it is considered to be a operator. It then encounters something called 3. When it goes forward, you even encounter something called 2, after which you encounter the end of the statement. So what happens? 32 is grouped together as a single number, a numeric constant, and then the remaining process happens. So this is actually what happens in the lexical analyzer. You simply scan. You go from the left, you go on towards the right, and then you do something called grouping. And you group things so that you can give it to the next phase of the compiler. Now let's come to the diagram. Okay, you group it. You will be getting a token. You will be getting the first token. You're not happy with that. You should again go on. You should go on and on. You should get the next token. Okay. You identify it. You store it in your symbol table. Okay. After that, you go on to the next token. So this is what happens. You give your source program into the lexical analyzer. You produce it as a token. You pass it on to the next stage. You're not happy with that. You go to get the next token. It is a cyclic process until all the tokens are generated. So once all the tokens are generated, you will be going into the next phase of the compiler, the next stage number 2. Now, if we go with the previous example, you have something like radius equal to a particular number. Okay, radius equal to 123.4. Now, the basic function of a lexical analyzer is to identify each token and then have it with a symbol table. Now, together with that, the lexical analyzer even does some extra jobs. Okay, the first job is like, imagine you have any comments. Okay, this is the radius. Imagine you write a comment like this. The comment is stripped off because that is actually not going to have any effect on your program. So it strips off this comment. Together with that, look here, I do have a small space over here. Okay, I do have a space over here which actually has no effect in my program. So all my white spaces, my blanks, my new lines, my tabs, all that are done away with. All these are done by the lexical analyzer. Even if you have any separators, all those are done away with. So that is also the job of the lexical analyzer, stripping away. And even it keeps tracks of the number of new lines. How many lines are there in the program? Now, tell me, why do you want to keep track of the number of lines in the program, sir? When errors are generated, you need to correlate with the line numbers. Okay, so just because of that, the lexical analyzer, it even keep track of how many lines you have and even the line number of each code. Now, together with that, as we saw earlier, it does deletion of your comments. It does compaction of your white spaces, all the unwanted spaces they are squeezed into. And then at the end of the day, what the lexical analyzer does is it produces a sequence of tokens as the output. Now, what we need to learn next is how are these identified and how are tokens generated. Now, this happens through something called input buffering. Now, there are two ways in which input buffering happens in the lexical analysis. One is via the two buffer input scheme, the first method, and the other is through something called sentinel pairs. We will first look into the two buffer input scheme. The first method, it is even known as buffer pairs. It is known as buffer pairs. And let's say you do have the same example. Radius is equal to 123.4. Okay. Now, here what happens is you use a buffer which is divided into two n character halves. N is usually your disk size. Okay, the number of characters on one disk block. It can be, let's imagine it is 1024 characters. Okay. Now imagine this is your disk block. I divide it into 2. And what happens is I read my particular line of code and then I stuff it into my buffer. Okay, so I'll just simply write over here I'm just writing it very huge so that you can be able to understand. Let's say RAD is equal to 123.4. Okay, you just put it in the first half. Now, for buffer pairs, you will be having 2 pointers. The first pointer is called the beginning pointer. beginning pointer, and the second pointer, it is known as the forward pointer, or even the look ahead pointer. So you have two pointers, the beginning pointer and the forward pointer, or the look ahead pointer. In the beginning, both the beginning pointer, I'll just name it as B, and this I will name it as L. Okay. In the beginning, both the beginning pointer and the look ahead pointer, it will point at your first character. Okay, and the beginning pointer will now not start moving. The look ahead pointer, just as the name denotes, it will start moving until a token is recognized. Okay, so initially I do have my B and L over here. Later, what happens is this L, now it moves to here. After which L moves over here. After which L is over here. Beginning hasn't moved, L goes on moving. Now, by the time L reaches over here equal to, it means that all things which are between the beginning and the L, yes, I have recognized a token. So the first token I have recognized is radius. Okay, so one token, it is now recognized. Now what will happen is, I've done with my first token, I need to go into my second token. So now what happens is, beginning moves, even L moves, and both of them are now at my equal to, and mind you, this is my buffer got deleted. Yeah. Beginning and L are over here. Beginning doesn't move, only L moves. L moves, and look here, the first half is finished. Okay, the first half of the buffer is finished, which means you have to load in stuff into your second half. So I do have the remaining of my code, 123.4. My code is finished. So what I do is I place an end of file over here. I place an end of the file over here. Okay, so my L moves. By the time L reaches over here, I encounter a number, which means, everything before that, between the B and between the L is a token. So I have recognized my next token. Again, B and L, they both point to a new location. B also points over here. L starts traveling. L goes on traveling up till here. When it encounters a semicolon, which means everything between B and L, it is a token, which means I have recognized my next token called 123.4. Okay, now B and L are again over here. This is as good as an end of file. I've reached the end of this particular buffer 2. Now what happens is, okay, I've reached the end of this. This is also gone away. Imagine I do have my next line of code. Let's say A is equal to 3.14 into radius. The first half is now preloaded. I write my next code. A is equal to 3.14 into so on. So this is how buffer pair works. You divide your whole this block into two equal halves. You have two pointers, a beginning pointer and a look ahead pointer. Initially, both are at the same place. Your look ahead pointer, it moves on until you encounter the beginning of the next token. Once you encounter the beginning, everything between the beginning and the look ahead pointer, it is treated as a token, which means, that particular line, you were able to recognize all the tokens. Now let us simply look into the algorithm. Okay. If forward, you have two halves. I call this the first half. I call this the second half. Okay. If forward is at the end, forward is nothing but my forward pointer. Forward pointer or my look ahead pointer. Forward pointer, look ahead pointer, both are the same. If forward is at the end of the first half, my first half is over, very simple. Reload your second half, put things into your second half. Forward is equal to forward plus 1. Else, if the forward reached over here, very simple. You have to put in stuff into your first half and then move to the beginning and then go on recognizing your token. So this is how the first method works, input pairs. The second method is look ahead code with sentinels. This is actually very similar to your first method of input buffer pairs. Now, first thing what you need to understand is what do you mean by a sentinel? The word sentinel means guard. Okay, if you remember in your first algorithm, you were having buffer pairs and then the end of the file, you had it towards the end of the statement. Now, in look ahead code with sentinels, what happens? At each buffer half, you will be purposefully putting an end of file. Okay, so let's see how it happens. Okay, you will be having a buffer pair. Okay, divided into half. Let's say, take the same example. RAD is equal to 312.4. Okay, this is my statement. Okay, I first put into my first half. What I will now do over here is in this particular method, I will be putting an end of file at the end of my first buffer half, and I will even be putting an end of file in my second buffer half. Why do I do it? I simply do it so as to easily identify the end of the buffer. Remaining, everything is the same. I will be having 2 pointers, the beginning pointer and the look ahead pointer or the forward pointer. Beginning pointer will stay at the beginning itself, doesn't move. Forward pointer, it goes on moving until it reaches over here. I am now about to encounter something called equal to, which means, everything in between my beginning and the forward, I have recognized it to be my token. This is a token. Okay. So once that is done, my beginning now comes over here. Okay. It travels, it reaches the end of the file, which means the moment it reaches the end of the file, it gives me the indication that this thing can be cleared. I can now clear my first half. Okay, so what I'll do is, I can clear my first half. Okay, now actually this 3.12, it isn't here. Okay, I've reached my end of file, which means I can clear my first half. I can now put things into my second half. I can put things into my second half. Together with that, I will even put the end of the file. Okay, my forward, it reaches over here, which means, I'm about to start reading a number, which means everything between my beginning and the forward is a token, which means my equal to. I move my beginning, both my beginning and the forward comes over here. My forward, it goes on traveling until it reaches over here. Okay, I have now encountered an end of file. Okay, which means this has to be cleared. This particular thing has to be cleared. So what I do is I will be clearing my number over here. Okay, and together with that, what should I do? I should even put in stuff into my first half, because in end of file reached over there, I should be putting. So I have something called A is equal to 3.14 into radius into radius. Okay, my forward, it comes over here, A. Okay, which means I am about to encounter a new token, which means all what I read till now, it is a token. So 321.4, it is my token. Now again, my beginning and forward happens over here together. Here you don't remember, don't forget, you put an EOF over here, you even put an EOF over here. So this is how look ahead pointer with sentinels work. Sentinel is nothing but a guard. The guard over here is your EOF. So in each buffer half, you will end it up with an endo EOF, and on encountering the EOF, you get an alert that you can load things into the next half and your previous half can be deleted away.